Great. All right. Thanks for the introduction, Ben. Hello, everyone. My name is Steve Woodrow. I work on infrastructure security at Lyft. And I think compared to, I think all the presentations we've got today are great. I think mine's going to be a little bit of a deeper dive into, I think, a few of the, um, I guess I would say like architectural pillars that I think have enabled us to go really quickly at Lyft and also deliver secure services. So what I want to cover today in terms of agenda is first of all an overview of our cloud environment, helping you understand, and our business and our culture, and helping you understand why we do certain things and why we value certain things that we do. Then I want to take you into the three kind of pillars. Number one, how we organize services at Lyft, and that includes how we organize AWS services into Lyft services, and how we kind of organize those in order to kind of make sense of what everything is going on in our cloud. Then talk about how we automate all of that using resource orchestration, and then following up with how we kind of manage identity and access management, IAM, in the cloud to keep everything safe and secure. And then if I've got time at the end, I want to dive into some cloud-native security tactics. These aren't kind of big kind of pillars, but sort of more just kind of things to whet your appetite about how you can solve certain problems using kind of cloud-native approaches that I think are really cool, and I would like to share with you all. All right, so first of all, an overview of Lyft in our cloud environment. So I saw a lot of hands raised when people were asking, kind of, do you know what Lyft is? Or hopefully, several of you have used Lyft here. For those of you who've never heard of Lyft or seen it before, we are a ride-sharing service that operates in the United States and Canada. Lyft has always had a history of moving very quickly. We started as a hackathon project. The company was previously doing something else in 2012. And since then, we've grown incredibly fast, and we're now serving 1 million rides every single day. And from a technology standpoint, Lyft is a cloud-native company, as Ben mentioned. We never had a data center. We never had, kind of a different approach. We've been on EC2 and then kind of growing into other AWS services since day one. We're now a decent-sized company. We're not as big as Netflix, but at least on the engineering side of things. But we have 500 software engineers, and we have a lot more technology resource consumers. And we use a microservices architecture with about 400 microservices distributed across 20,000 EC2 instances. So we have a decent scale in AWS. The other thing I want to talk about, and I think this is going to be important because this sort of note flows through the rest of the presentation, is our engineering culture. One of our key values at Lyft, one of three, is called Make It Happen. What this really means, if you expand it, is that we encourage and try to empower all engineers to take ownership and focus on impact as they're doing their jobs at Lyft. And so when we dive into this means a few different things. We practice a DevOps model of kind of service management. So engineers on certain teams, own the services that they build, they deploy them, and they maintain them. They're the ones who are responsible for them. To sort of make sure that everything is kind of done in a somewhat similar way, we rely on heavy automation supporting our software development process. We do a lot of CI and CD with pipelines and stuff like that, and also automated monitoring. And then finally, I think different companies have different approaches here. We have few change management checkpoints or gateways that have human gatekeepers, and so we have a lot of automated testing. But we as the security team especially try not to get in the way of people making it happen. That said, we still try and help them ship things securely with all that automated stuff. And all this together means that engineers at Lyft are deploying hundreds of times a day. I don't know if this number is even, I think it might be higher than this now, but 200 deploys every single day. And so we're moving really fast. And so these priorities kind of guide a lot of the decisions and the architecture choices that we make that I'm going to go into in the rest of the presentation. All right, so you're going to unfortunately hear this a lot today. Let's talk about how we make cloud security happen at Lyft. So first off, the sort of primary thing that we need to do is figure out how we're going to organize and talk about all of our cloud resources. So as I mentioned, we've got tens of thousands of EC2 instances, millions of other cloud resources like S3 buckets, Dynamo tables, SQS and we need to figure out ways to kind of build abstractions that are higher than each individual thing to reason about what are these things and who owns them, and should they be allowed to do things or not do things. And so we need to create these abstractions to be able to think about things and say, this sounds safe, yes, go for it, or maybe we would recommend you approach this problem in a different way. And I know this sounds kind of complicated, talking about abstractions, but we already do this all the time in kind of conventional security stuff. if you talk about, is it okay to put like this process, should these two processes on a server trust each other, or should they be isolated? Are things on the same subnet or the same VLAN trustworthy? And so we need to sort of like figure out sort of similar groupings for the cloud. And so the way we do this at Lyft is that we sort of take a bunch of AWS services and kind of name them in a certain way, and we organize that and call that a service. And at each service at Lyft, there's sort of one application deployed. That means we get a bunch of good isolation properties in terms of relying on virtual machine isolation, as well as IAM isolation of all the resources that go along with that, and I'll go into that in a moment. Everything inside of the service boundary, so like the EC2 instance, S3 bucket, et cetera, they're all kind of trusted and kind of all grouped together. And then by default, things that are not in that service don't get to talk to those things. And so services are in charge of managing access to the resources. So first of all, if we're going to kind of organize the services, naming I think is really important. And this is what a service name looks like at Lyft. So hopefully, many of you guys are probably already seeing what's going on here, but just to break it down for everybody. The first part of a service name at Lyft, they have these three parts, is the actual kind of service. So this tells you something about the repo it came from, the function that it performs for a business, in this case, web service. Next is the environment, and this is the environment in which it's deployed. And so you might have a staging or production environment, different AWS accounts. It's kind of up to you to figure out what makes sense for your business, but we use this for change management, where changes get deployed to our staging environment first and tested before they move to our production environment. And then finally, because you might want to run applications in different regions, we need to have a key in there for the region as well. So let's start gluing this all together and talking about how we name and organize everything at Lyft. So as I mentioned, everything at Lyft kind of revolves around this application, some code that is deployed in our EC2 environment that, or our AWS environment that's delivering value. So we take, and you see in this diagram here, we take some application code from an application called web. It's deployed from a repo called web, and it gets deployed onto EC2 instances called web in an autoscaling group. And that's kind of the fundamental, like how we deploy what a service looks like at Lyft. And you can see that all of these, the EC2 instances and the autoscaling group, and everything is named in that same way. And then we can sort of take this a step further. And this is all going to sound repetitive, but it'll make sense in a second. We need to then put some other glue here to kind of make the service actually work. So we need to get traffic to our service to actually kind of make it accessible to clients. So we need to put an elastic load balancer there. And that's going to be named the same thing. We're also going to put a Route 53 CNAME there and also name it the same with a CNAME that looks the same to point to that thing. We're going to create a security group to isolate the instances in that group from everything else in our AWS account. It's also going to be named the same thing. We're going to create an IAM role to grant access to other resources in the account. And then we're finally going to need to store some data. And so we're going to create a Dynamo table that's prefixed with that name. And we're going to create an S3. There already is an S3 bucket, but we're going to create a subkey that is named to that thing. So you can see that everything in this account is named in the same way. And so that means when you go to the AWS console, if you get a note from AWS saying, hey, there's a problem with some resource, it's immediately clear what service this thing belongs to and who owns it. And so it makes kind of figuring out what's going on really easy compared to having things that are named in all sorts of different ways. The other thing that this makes really easy is automation. Because we have the same naming scheme, we can go a step further and automatically say, when we create a service, let's automatically grant access to some certain other resources that are named in the same way. And so you can see this in this stage. When we create an IAM role for a service, we automatically grant access to Dynamo tables that are prefixed with that service name. And we automatically grant access to certain S3 buckets that also have a subkey with that service name. And this is all automated. This is all something that we don't have to think about when an engineer creates a new service at Lyft. And by default, they have a sort of strong security policy where access to that Dynamo table is only granted to the service and not to any other services at Lyft. And so this makes it really easy for people to move quickly without thinking very hard about, or us thinking very hard about, what is the right security policy for this thing. So overall, this has served us really well at Lyft. And so I just want to sort of reflect on what this gives us. So when we have this standardized approach for what goes into a service and how a service is named, we get a bunch of things, not for free, but they become very easy. As I talked about already, It makes ownership and figuring out kind of what a resource belongs to and which team owns that service is very, very clear. Inventory also becomes easier because when something doesn't fit this naming scheme, then suddenly you're like, where did this thing come from? And we can dig into that more deeply. And also for accounting, we're starting to, as we become a bigger company, need to control our costs better. And so this naming scheme lets us attribute all of these resource costs back to their owners. Depending on the size of your org, one of the things that's been really valuable for us is that this naming scheme and service organization model creates a common mental model for every engineer at Lyft. And so you can switch teams, or you can read one service's docs, and it makes sense when you switch to another service or look at another service, because every service is created in roughly the same way, as opposed to needing to create special documentation or kind of needing to come up to speed whenever you look at a new service. And finally, as I'll talk about in the next section, this common naming scheme and common organization scheme makes it really easy to automate a lot of this stuff, and that's something we take advantage of heavily. And finally, as I already mentioned, the IAM policy is really strong by default. It means that services are pretty isolated, and that's I think a really key model to making sure that it's easy to understand what's going on with all of your services in the cloud. If you do have bigger services, you might need to split them up to kind of get that same property. All right. So with that, I want to now talk about how we automate all this stuff, because that's the next key, I think, in our ensuring that we have a strong and well-organized and safe cloud environment. So hopefully everyone here knows, or at least is sort of conceptually familiar with what cloud resource orchestration is. This is the idea, I guess, of rather than going into the AWS console and manipulating resources directly, you have some code or some way of saying, these are the resources I want to exist, then you use some separate tool to kind of go and tell AWS how to make that happen. So common tools in this space might be Terraform or CloudFormation and things like that. So orchestration at Lyft gives us a few different benefits, and I think a lot of organizations can reap these same benefits. Number one, you get a repeatable workflow. You don't have people making changes in the console, making changes on their laptop, kind of making changes that are unrepeatable. By doing your orchestration as part of a deployment process where there's only one way to make changes, you kind of know where every change came from and why it happened. Treating your infrastructure as code is also really valuable because it means that you can start applying some of your application security processes to your infrastructure. So if we're talking about, I want to open a port in our security group, making like a firewall change, I can propose a change to our infrastructure repo and then have a conversation with the application owners, with our infrastructure team, with all the people who might be involved in that. And it's not, and then once we're all on the same page, we can agree to it and we go and make the change. And it's sort of separate from, it's easier and faster than having to create tickets and talk across different teams. Finally, the last thing, and we use this, it's no substitute for actually checking the AWS API, but excuse me, sometimes if you want to kind of quickly understand where is the security group used, or where is, which security groups say have like a CIDR rule in them, it's often really fast to check the code for this first, because you can use your code search tools, which are often faster than, again, talking to the AWS API. So how do we make this go quickly at Lyft? How do we make it happen? I think it would be totally rational for you to want to sort of centralize all of your orchestration runs in one kind of central infrastructure team. But that means that team becomes the bottleneck for every change at your company. And so it's going to make teams go slower, and it's going to make the sort of that team kind of have a very operations role when they could be focusing on leveling up all of your infrastructure. And so the way that we have chosen to solve this problem at Lyft is we have two levels of orchestration, and I'm going to dive into that in the following slides, where individual services, kind of single applications like I talked about before, are self-service, and they can deploy those orchestration changes using their normal deploy process. It's all integrated. So when you deploy code, you also deploy creating new AWS resources if you ask for them. And then for higher risk changes, or changes that affect our entire account or region or something like that, those are sort of treated as more infrastructure changes, and those are managed by our central infrastructure teams. But it takes the load off and allows teams to go at the pace that they want to go. So with that, that kind of lays out our philosophy, but let's talk about how we actually build that. So at Lyft specifically, we use Saltstack for our AWS orchestration. I didn't mention it at the beginning because I probably wouldn't recommend using it, but it's worked for us. And the way that teams create a new service or start kind of like adding new resources to a service is they start with a service template. that is sort of like stored in a central repository and is used to kind of create a service-specific repository. And so I have an example of this on the screen here where we've got some SLS files. These are sold files. And team will use that as a starting point to create a new service orchestration module. And in that module, there's a bunch of different variables and kind of other things that get filled in automatically for them. And then when they go and deploy this, there's a bunch of other things that come along for the ride. There's variables that are kind of about, what's the service called, where is it running, as well as some base templates that are a little bit more centrally managed that then get all merged together and deployed out with our deploy tool using Salt to actually affect these AWS resources. And so this means that when a service team is making changes, they focus on kind of what's specific to their process and their application, and then kind of a bunch of stuff is done, all the hard work is done for them to ultimately make AWS the way that both they want it and we want it. So let's show you how this actually works in practice. So here's an example. And by the way, this is an open source repo. This is on our GitHub organization, so github.com/lift/confidant. And you can take a look at this at your leisure. So Confidant is an application that we've open sourced. And just to kind of make this kind of very clear, there's some application code, there's some Python code in the root of the directory. And then down in the Salt orchestration directory, there's this Confidant SLS file, which is the actual orchestration code. And you'll have to bear with me. I don't like to show code too much on screens, but this is just to sort of explain what's going on here. As I mentioned, the orchestration code this is similar to Terraform. We say, I want a resource to exist. And so in this case, we're creating a IAM role. And we're sort of writing the policy for that IAM role down further. But what's cool about this, and you can sort of maybe see where I'm going with this, is that there are some curly brackets, and those are the templating parts of this thing. So if we look at this, the name of the IAM role is going to be templated with the cluster name, which is that 3-part application name that I mentioned at the beginning. And then also, and this is where I think it gets really cool, is the automatic templating to kind of other resources, in this case a Dynamo table, based on the service name. So without having to kind of do anything manually, when a team deploys this, they get an IAM profile that says, or an IAM role that's say called Confidant Production US East 1. And it automatically grants access to Dynamo tables that start with Confidant Production US East 1. And we didn't have to review it, and they didn't have to review it. It just kind of all comes for free. And so when they deploy it, that stuff gets filled in there, and that IAM role gets created. And now for the deploy process, just to elaborate a little bit on what I was talking about earlier. When a service team wants to do a deployment, they follow the top path. We use Jenkins as our deploy tool, and so a service team will make a change in their Git repo. They'll then kind of do our code review process on it. They will merge that, and then the change is ready to be deployed. And then they go to our Jenkins web console. They start the deploy process. And in that deploy pipeline, at the various stages, we have like a staging stage and a production stage. In addition to kind of creating building the code and pushing it out to the service, it will also create the AWS resources that are asked for as part of that deployment step. And so we have Jenkins doing kind of both our not the same Jenkins building the code, but we have a Jenkins kind of affecting the deploy, and then also affecting the AWS account to sort of support that. And then for our infrastructure stuff, or the stuff that's really critical, say like a common security group or Rev 53 entries or things like that, we have the infrastructure repo, which is sort of deployed through the step in the bottom. And then the thing that I think is cool about this, and kind of related to all this templating stuff, and the infrastructure teams doing the hard work so that services team can do the stuff that's focused on their job, is the service deploy. If you look at the purple arrow in the middle here, the service deploy will update, or will pull in templates and details from this common infrastructure. And so it's up to the security team and the other infrastructure teams at Lyft to say, this is, say, what a common elastic load balancer cipher list should look like, or this is what a common IAM policy that should be in every IAM policy looks like. And then when service teams deploy their changes, they automatically pull that in. And so it means that we have sort of one common place for kind of boilerplate code that is important for us, but not important for them. But when they do the deploys on their own, it automatically pulls it in. All right, so in terms of lessons learned for this at Lyft and how we're using it, overall this has been, I think, really, really valuable in terms of enabling us to go really quickly, and also kind of maintaining a bunch of things in common across our infrastructure. Challenges, I'll go through really briefly. These are just things that I would sort of like encourage anyone to keep an eye out for if you're deploying this yourself. Um, Fleet-wide changes. So let's say you want to upgrade the type of instance that, say from a C3.xlarge to a C4.xlarge across your fleet. You need to either automate that in some other way, or you need to get every single team to deploy that, because that is one of the parts that's stored centrally, but not actually affected in AWS until you do a deploy, if you remember the previous diagram. And so that is a bit challenging if you want to sort of do stuff like that for your teams. I mean, if you're okay with it taking however long it takes for them to deploy their service, it's not so bad. But if you want to kind of make a change quickly, you either have to deploy everything or find a different way to solve that problem. A second thing that we found, and this depends on your team and their level of sophistication, but in our case, a lot of people just want to sort of go quickly and solve their problem. They want access to a database and maybe some other things. They don't want and don't need to have fine-grained access over IAM policies and things like that. And so I think it would be easier for everybody, both us and our development teams, if we could give them something that's a little bit simpler, like maybe a menu of 5 options rather than making whatever changes they want. And finally, really briefly, you need to think of a way of how to make, if you're going to do this approach of sort of separating, allowing certain teams to do their own orchestration, is finding a way to make sure that those changes are safe. So making sure that teams aren't accidentally or intentionally creating opportunities to elevate privilege through their own service changes. Another thing to think about, and I think that, I'm not sure if Ben mentioned this morning, but it's pretty common in red team exercises. Once a red team finds a Jenkins box, to sort of view it as like, okay, we've won, because those Jenkins boxes are always going to have high privilege IAM roles, because they need to orchestrate all of your AWS resources. And so this is something that you need to think about if you're going to use Jenkins or another similar tool to manage all of your AWS resources. I still think it's more valuable to do this than to do it in some other way, but it's just something you need to think about. If you are going to use Jenkins in particular, you need to make sure that you're not using that same Jenkins instance for running tests, because otherwise you might be in a situation where your test code that is not code reviewed might be running with IAM root privileges, which is not something that anybody wants. Okay, so that's orchestration. That's the second pillar of security at Lyft, or security of our cloud infrastructure at Lyft. And the last part I want to talk about is identity and access management. And we break this down into 2 different categories. The first that I'll talk about is humans, and how humans interact with our AWS environment. And then the second is infrastructure at Lyft and machines. So first of all, starting with humans, hopefully this is clear to everybody, but just in case, when you're managing AWS accounts and through AWS IAM, any changes you make there have the potential for account-wide blast radius, because you are potentially allowing people to have administrative access to your account. And so you're likely to want to give people administrative access to account, but you need to make sure that you're doing that in a safe and controlled and managed way. So I think however you choose to do this at your company or in your business, you're going to want to choose the strongest and best managed tool that you have the most confidence in for managing users' roles and policies. At Lyft, because we didn't have a strong single sign-on solution at the time, we chose to use IAM users and orchestrate those users when people are onboarded and offboarded with the company. Alternatively, and I think this is probably a better direction to go in, it's the direction I would want to take now, is to use single sign-on from some other service like ADFS or something like that, and allow your users who have identities in their single sign-on service to sign into different IAM roles. Anyway, we use IAM users, and so that's the context for this part of the presentation. But I want to talk about how we make it happen and how we make this go fast without being a super huge operational burden. Number one, we allow our users to self-service their own credentials. So this means that users can change their own passwords. Users can update their MFA device when they get a new phone. Coinbase has a good set of tools there that you guys can take a look and potentially use if you'd like. As I mentioned at the beginning, we take this DevOps approach, and so we need to allow engineers to do kind of certain things on their own, because it's involved in maintaining a service. And so the approach that we've taken here is we allow engineers to list resources and kind of look at, when they log into the AWS console, everything looks normal. But if you try and either do something destructive or look at data, that's the point at which you sort of hit a wall. You need to elevate your privileges. And then we use rules to kind of manage those elevated privileges. And then finally, And in the principal of least privilege, for things that are higher risk, like administrative accounts, those are the ones that we do manage access to tightly and require processes to get those. So let's talk about how we make this work. Um, so this is a kind of a very, like a bit of a simplification of how we do this at Lyft. But in this diagram, we've got two users, one of which is in this engineering group and that has some permissions, and then a second user, which is in this admin group. If we look at the engineering group first, you can see that there's a bunch of list and describe and get calls, things that are pretty safe and pretty innocuous inside an AWS environment. And this means that if you log into the AWS console or use the AWS API, you can do these things right off the bat. But there's nothing sort of that's more dangerous in there. The second user that's in the admin group is able to assume a role that is called an admin role and allowed to do other things. So that's how we set up these users in groups. And then we've got some roles here. And this, when I mentioned kind of elevating your privilege, this is how we manage this. So I didn't show it in the first diagram, but the groups in the engineering group, or the people in the engineering group, are allowed to assume a DevOps role, and this allows them to do slightly more dangerous things, like terminate an EC2 instance if that EC2 instance is bad. And then, as I mentioned before, we've also got this admin role, which allows all actions on all resources. It's a privileged and higher risk role, and so we want to restrict it. And just in case you're not familiar with the way IAM works, the way that users go from a group to a role is making an assume role call. And so when a group is in engineering, they can either, again, do this through the API or the console. They can assume the DevOps role and elevate their privilege. What this also means is that if there's a user in user one who's only in the engineering group and tries to assume role, the admin role, they will be rejected and saying, you don't have permission to do that. So the thing that I haven't mentioned yet, but hopefully everyone is sort of thinking it, is what about MFA? And this is the thing that's really important to figure out in AWS, especially because there's a few tricks to it. You might make your users add MFA to the AWS console. They can do it voluntarily, and then that will be enforced every time they sign into the AWS console. But perhaps AWS doesn't make it clear enough. They might still be able to do those actions with the API if you don't write your IAM policies in a way that enforces MFA, whether they use the API or they use the console. So there's a couple different ways to do this. We do both at Lyft. The first is to write add a condition component to your IAM policy that allows assume role, and you can put a condition key in there. And there's docs on the AWS site if you want to get into more detail, called multi-factor auth present. And so what this will do is when AWS is about to do the assume role call for you, it says, hey, has this user used MFA to gain their access? And if that's not true, it will reject this call, even if the user otherwise had that permission. The other thing we do, and I think I like this because it makes me feel kind of really confident that people aren't going to be able to assume these dangerous roles without a multi-factor auth to prove that it's really them, is we put it as a policy document on the policies themselves. And so what this means is regardless of how you manage to find an IAM policy to assume this document, or assume this role rather, we are always going to enforce that you have that multi-factor auth present. And so this makes us feel really good that it's only our authorized users that, and not sort of someone who's stolen credentials off your laptop or leaked a password, that are actually doing these dangerous roles at Lyft. So speaking of, we talked about a bunch of people who should log into our Lyft account. Now I want to talk about someone who should never log in, and that's the root account. The root account, this is the first account that you ever get when you create a Lyft account, or an Amazon account. And this is the account that you then use to kind of set up and manage everything else in your account. One thing that is, again, I'm not sure if it's obvious, but the root user of an AWS account can never be constrained. You can't write an IAM policy that will prevent them from doing something. And so this means that this user is pretty dangerous because they can do anything to your account, and once they're in, there's nothing you can do about it. So I think number one here, you don't want to use this account except when you don't have any other alternative, and instead use IAM users or IAM roles. There are a couple things you need to do that I mentioned on the screen that you do need the root account for, but otherwise try and never use it. Because grabbing these credentials, are so risky, MFA is a must. We use physical tokens, these black devices that you see on the side here. because we can put them away somewhere and never touch them again, except when people do need to access them and they're in a safe or a security container. Um, we also don't issue IAM credentials from this user, again, just because it's so dangerous. We use an IAM user that has similar permissions when we do need something like that. And then finally, the last thing, which is pretty powerful because it just lets you know that something is really wrong and like potentially like the code spaces incident, go and do something about it, is we alert on any use, any CloudTrail action done by the root user. Because again, that should just never be happening in our account. All right, so that's users in our account. Now let's sort of quickly talk about machines. The big takeaway here, I don't have as much to say about this part, is that you want to use IAM roles everywhere. It's sometimes tempting to use IAM keys because there's, you want to sort of put them in some credential management system or something like that. But ultimately, when you use IAM roles and use the AWS metadata service, you're making AWS do the hard work for you in terms of distributing those and making sure they're rotated periodically and doing everything safely. One of the challenges we've had is we have partners that we share data with that want an IAM key or want to give us an IAM key, and we've pushed them really hard to use roles instead. It's possible to allow a user in one account to assume a role in another account, and that's how we prefer to allow users to, in different organizations outside of Lyft, to gain access to specific roles that they need to say, access an S3 bucket. The other thing, as Ben mentioned, is depending on what you're doing, you really need to take care to protect the metadata service because that can, again, lead to access to whatever credentials that instance has. There's a couple different cases in which this can come up, and we have a couple solutions here. Number one is Docker containers. If you're running Docker and you don't want every container on that host to have access to the instance role profile, you can use a proxy to intercept those calls to the metadata service and do something more useful with them. We've open sourced this thing called metadata proxy that will let you kind of give an individual instance or an individual Docker container a different profile than the kind of underlying AWS instance. The other thing, if you're doing webhooks, this is another good way to accidentally give someone access to your metadata service. Stripe has open sourced a thing called Smokescreen, which lets you, again, proxy outbound requests from your server. And if something does look like it's going to hit the metadata service, it drops those requests. And so these are really good ways to protect the metadata service. Yeah, so recapping here, one thing we learned the hard way is that IAM users and access keys, especially for non-humans, can get really messy really fast and have major consequences. We had a case where we had some, and they weren't kind of handled unsafely, but they just became really difficult to change to IAM roles later because everyone depended on them. And then once they were dependent on, it became that much more work to kind of change and manage that migration. So if you can avoid it, I would start with IAM roles and never do users if you can. Because in the best case, it just becomes hard to change. Worst case, you have one of the incidents that Ben talked about where you accidentally put that key on GitHub or something, and then all sorts of bad things will happen. If you are going to use users, you do need to have an MFA enforcement story and a key rotation story for all of those. It's again, something that's easier to think about at the beginning rather than figuring out later. And then finally, as I mentioned at the beginning, I would strongly recommend people thinking about using single sign-on instead of IAM users if you can avoid it, at least for non-admin roles. If you want to sort of separate administrative access to your account, I think it's okay to have users with long passwords and MFA tokens there. But for people who just need to log into the console and take a look, single sign-on is probably going to be what you want. This is going to, especially the fewer AWS users you have, the less you have to worry about them, the less you have to reset their passwords, and instead focusing on improving security of your organization. Okay, so with that, we covered the kind of three kind of big architectural things that I think we've done that have helped us run a secure cloud while moving quickly. And now I want to dive into a couple of things that, like I said, if you think about problems a little bit differently and kind of through a cloud native lens, you might be able to improve your security in different ways at your company as compared to a data center. So first off, I think autoscaling is really cool, and it enables automatic patching, similar to what Will mentioned about what they're doing at Netflix. So for those of you who aren't familiar with autoscaling, this is basically saying to AWS, please create a group of instances and make sure that it's always at least, say, 3 instances big. And if one goes away or one is terminated, it'll bring a new one in place. And because if you're running in this environment, it means that you can lose an instance and nothing bad will happen. It means that you can actively get rid of instances and kind of take advantage of the side effects of that to make sure that your cloud is secure. So at Lyft, we update our instances when they launch. This would also apply to you if you're updating AMIs and kind of doing deploys that way. And so what this means is when we launch a new instance, we know that it's in good shape. And we take advantage of this by getting rid of old instances and ensuring that new ones, when they do come up, come back in an up-to-date way. And this lets us manage kind of how kind of patched our fleet is. And so I'm proud to say that I think like 90 or 95% of our instances have a lifetime of less than 14 days. And this means that they're all up to date. There's nothing kind of unknown lying around on them. And it also helps us make sure that our AWS orchestration is working well. We do this in a couple different ways to kind of manage this 14-day thing. The first one is load-based autoscaling. And so if you run a site that, like we do, that has a lot of kind of changes between peak traffic and the trough of traffic, you can change the way that your autoscaling works to terminate old instances first. This means that an instance that was created 3 days ago and is no longer needed, it goes first before an instance that was just launched. The other thing that we do, and this riffs off of some of the things that are named at Netflix, is we built a simple tool called Reaper Monkey that looks at instance lifetimes and explicitly terminates old instances. I think as sort of in the same way that Cloud Inquisitor had challenges in terms of choosing what to terminate when, we had to do the same stuff here in terms of starting with a blacklist and also scheduling termination at different times to make sure that we weren't terminating critical instances. But overall, this has enabled us to do non-critical patching in a way that is totally transparent to our service owners and kind of still achieving really great coverage. The second thing is I would encourage you to trust no one else's network. One of the cool things about cloud infrastructure is it starts out isolated by default, and that means that you can have a really small blast radius by default. And with some of the stuff we're going to talk about, we've talked about this morning and we'll talk about later this afternoon, are going to dive deeper into those things. Unfortunately, one of the things that people do often, Lyft did it early on in its time, and I think a lot of people are kind of have good reason to want to do it, is to interconnect their cloud network with their office network to access it or something like that. And that's going to lead to increased blast radius. This can come in this sort of form, both that you have to trust whoever's running your office network, and it also means that whatever, if you do a compliance test of your cloud, you have to include your office and vice versa. So one thing that we do, and I think works really well for us, is we run our VPN terminator inside our cloud. This means that there's no kind of trusted networks or sort of linkages between our office network or any of our other sites where we have employees and our cloud. And so this takes a little bit more work up front maybe, but it means that access from our office is the same as access from your home, is the same as access from Starbucks. And so we have sort of one common way for everyone to access the cloud when they need to get onto that network. Third thing, and this is sort of more of a, just to kind of, whet your appetite or sort of set your sights about what you can do with the cloud. AWS makes you do things differently. Sometimes it makes easy things hard, but it also makes hard things possible. And it often does this because you pay for resources kind of minute by minute or second by second, and you can ask for a lot of resources at once. And so by using automation and say, kind of doing, solving your problem into something that can be solved with a big batch job where you can pay for a lot of computers for a small amount of time, you can solve problems in different ways that might actually be better than what you're currently doing. I'll just give you 3 quick examples of this. Airbnb wrote an open source tool called Binary Alert that does kind of malware analysis for every malware or binary sample that they get off of all of their sensors. And whenever they add a new Yara rule or whenever they kind of find something of interest, they're able to rescan their entire corpus for a few dollars using AWS Lambda. And they don't have to manage any infrastructure to get this. And so it's a really, it's a different way to look at this problem, and it's, I think, pretty cool. And it's something that only AWS enables. A second thing, a lot of us, like we use Elasticsearch in an ELK stack. I'm sure a lot of you use Splunk. It's great, but sometimes it's a challenge to manage how much data you retain because you've got to sort of say like, do I retain more data but I have less retention period, or do I maintain my retention period and have kind of not all the data that I want to solve an incident? And in AWS, sometimes you don't have to choose. For instance, if you're logging CloudTrail or flow log data, you can dump all of that data to S3, and then S3 doesn't cost that much to store data in. And then only when you need to do an investigation, you can use an AWS tool like Athena to run queries on your data, and that's sort of finally when you have to pay, instead of, having to make those hard decisions and pay upfront for data that you may never look at. Third and final thing, AWS organizations makes creation of new AWS accounts basically free. And so if you want to kind of go beyond the isolation model that we've taken and sort of really isolate every single service or application you deploy in your cloud, it's totally possible to do with AWS organizations. And that gives you, again, a level of isolation that just kind of wasn't previously possible, and is free because Amazon doesn't charge you for those things. So just something to think about. And so with that, thank you for your attention. I would love to answer any questions, but we can also chat offline or later if you want to start eating lunch.
Hi, this is a question from a remote attendee. Relevant to orchestration as a pillar, what and how are your security teams monitoring the pipelines and operational environments? Are there requested changes to ops orchestrated through the same tools?
So can you repeat the question again? Or repeat the second part, please?
Sure. It was what and how are your security teams monitoring the pipelines and operational environments? Are there requested changes to ops orchestrated through the same tools?
Okay, I'll answer the first part first. So we do both monitor using CloudTrail kind of all of the orchestration events, and do have kind of monitoring and alerting on things that are unexpected. We also do have some, and we need to do more, but I would say kind of analysis of what the changes that are going to go out and making sure that those are safe. But those things both do alert our security team. I'm not sure about the second question, but I would say that for people who do want to make changes to their application orchestration code, that's something they, if they're doing something that they're not sure about or they need help with, that's something where us or the infrastructure teams at Lyft do get kind of involved in helping them figure out what's right for them or their application. If I didn't answer that second part, I'm happy to clarify, and I can talk some more.
Hi, thanks for talking about orchestration. I think that's really what we're all trying to achieve, like move fast. Agility without anarchy, I think, is the idea. But what are some of the foundation requirements in order to get to orchestration? Did you have some enterprise architecture and security architecture patterns that you could make actionable through the pipeline, or what was the approach to get to the orchestration?
I guess this is one of these areas where it was we started out as a cloud, as like I said, a cloud native company, and so we all of this stuff got started by infrastructure engineers, kind of thinking about what is the thing that's going to let us scale most easily, and let's kind of help everyone do that easily. So as we mature and develop, kind of more security policy and kind of how to implement that, we kind of go and make those changes. But it's not. I wouldn't say it's it's not coming from policy, but more kind of updating kind of things that are in the developer workflow to get their job done. So if we want to change the way that people configure services by default, we would update a template, or we would kind of, if we need to do a migration, we would help everyone do that migration. And so it's probably less structured than you're talking about, and I think more just what is how do we kind of codify the best practice that we're looking to see, and kind of help developers make that happen across all their services.
Hi, are you using third-party NGF firewalls in the core or just the native AWS security groups?
Yeah, so we We're just using AWS security groups. I don't think our network architecture and sort of the, some of the places in which we would, have to create a bottleneck in order to use like a software-based next generation firewall would scale very well for our environment. So instead, we have to take other approaches. If we want additional kind of monitoring, we have to do it on hosts and things like that.
So regarding the multi-factor authentication that you put in policy, the conditional, right?
Yep.
Is that something that, could it be done at the organization level through service control policies and lock it down to a particular OU?
That's a good question. We don't use
Okay.
AWS organizations because it's a relatively new service. So it's possible you can do that, but I'm not 100% sure. I don't know what you're allowed to do or not allowed to do. I thought service control policies are mostly on like actions and resources, but don't quote me on that.
Okay, yeah, thanks.
Okay.
Hi, do you make use of third-party WAFs or AWS's WAF offering at all?
We don't. Again, it's just sort of like not something that, like, I guess one thing I didn't mention here, but should mention is we do have, we've built a custom web server that's also open source. It's called Envoy, and we use it to do all the routing and kind of other kind of HTTP-based stuff across our microservice architecture. And so we do have some controls and rate limiting and other things like that built into that, but it's not, we don't use any of the kind of off-the-shelf WAF things. We don't have, we also don't have compliance requirements, I guess, to use a WAF. And I mean, I guess I'm a little bit skeptical of the value of a WAF. I know some people probably do find them valuable or need to check a box to, and that's why they use them, but we don't kind of have anything that's looking into payloads.
Okay, thank you.
Thank you, Steve.